So in this problem, we want to take this series and express the series in sigma notation. So here we have a series 6 plus 9 plus 12 plus 15. We see it's a finite series with only 4 numbers, and we can label this a sub 1 as the first term, a sub 2, a sub 3, and the series only goes to a sub 4. And we want to express this in this format over here in this notation, this sigma notation, where this Greek letter sigma means the sum. So that's what we're trying to find with series, is the sum of the numbers in the sequence. And we have some starting value that we're going to input into the formula, and we have the finishing value, or the last number for n, that we input into the formula. So what we want to do is we first want to kind of examine this series here and see how it's changing. Well, from a sub 1 here to a sub 2, it looks like we've added 3. And as you go along the series, we see we just have a difference here of positive 3. So it looks like we have an arithmetic sequence here, or series, because we're adding. And we know that we can find the common difference, which we've already found, but our formula, the common difference is going to be equal to a sub 2 minus a sub 1. Which our common difference is equal to 9 minus 6, or 3, which we've already found here and proved there. So, but that's an important part because we know that it's an arithmetic series. We know that the formula for this, or our explicit formula, is a sub n is equal to a sub 1 plus the common difference times n minus 1. Where n is just the number of the term that we might be looking for. So here we can figure out this explicit, and this is our formula. This is going to be the formula that we put next to this Greek letter sigma. So we can fill in a sub 1. We know a sub 1 is 6, so we can plug that in here. We know that the common difference is 3, so we can plug that in here and then simplify to figure out our formula. So a sub n is equal to 6 plus 3 times n minus 1. And then we'll just go ahead and simplify by distributing 3 times n and 3 times negative 1, which is going to give us 6 plus 3n minus 3. And then combine like terms. 6 minus 3 gives us positive 3. So our final formula here is 3n plus 3. So if we come over here and do our sigma notation, we can say, all right, well, sigma notation, the sum of 3n plus 3. And we got to figure out where to start here. Well, a sub 1 means the first term, so if n equals 1, will it give us 6? If we input 1 into n, we get 3 times 1, which is 3, plus 3 is 6. So we know that we're starting with 1, and there are 4 terms, so we go to 4. And this is the sigma notation, and the answer to the question to express the series in sigma notation. And you can check your work here by, like I said, taking 1, inputting it in. We get 3 times 1 plus 3, which is 6, which should equal a sub 1. And we could continue with that process. A sub 2 should be 3 times 2 plus 3, which is 6 plus 3, which equals 9, or the second term in the series, and so forth.